Hello everyone, welcome to MK Academic Solutions. So myself D. Chinna, one of the faculty member in MK Academic Solutions. I am your chemistry lecturer. So in this video we are going to discuss about the chemical kinetics chapter, and this is the third part of the chemical kinetics chapter. Okay, already we completed two parts. Okay, in this video we are going to cover theories explains the rate of reaction. Okay, theories, mainly theories which explains the rate of reaction. We know what is a rate of reaction. Rate of reaction is nothing but speed, with how much speed the reactant is going to be converted into product, that is the rate of reaction. So here this theories explains how the reactant is converted into product. Okay, so what is the process is involved when a reactant is converted into product. Okay, so here mainly we are going to cover collision theory, transition state theory, and limitations of collision theory. Okay, so first let us see collision theory of rate of reaction. Means how a reaction is going to be takes place according to the collision theory. And this theory, it is also called Arrhenius theory. Okay, collision theory is also called Arrhenius theory. So here, according to this theory, according to this theory, a chemical reaction takes place due to collision of reactant molecules. According to this theory, a chemical reaction, a chemical reaction, a chemical reaction takes place due to collision of reactant molecules, due to collision of reactant molecules, collision of reactant molecules. Okay, so here what is the meaning of collision? Collision means hitting together. So means two reactant particles are going to be hit together. When they hit together only, the reactant is going to be converted into product. Okay, but here each and every collision will not give us product. Okay, each and every collision is not give us product. Only few collisions will give us product. They are called effective collisions. Okay, so for example, it is the reactant molecule. Okay, so A2 consider, and B2 you consider. Okay, consider this is the B2, and they are going to hit together. They are going to produce the A to B. Okay, A to B or 2A. Okay, this is A2 and B2 and 2AB. Okay, this is the product. Means these are the reactants, and this is the product. Okay, so now here how this A2 and B2 are converting into product like AB, because collision means hitting together. Okay, collision means what? Hitting together means they are touching with one another. That is known as what? Collision. When they collide with one another only, they will give us product. Okay, according to this collision theory. And here in binary molecules, in case of binary molecules or simple gaseous reactions, these collisions are very high, and the number of collisions takes place per second is called collision frequency. So the number of collisions takes place the number of collisions takes place per second is called collision frequency, is called collision frequency. Okay, so your collision frequency indicated with the Z. Okay, collision frequency indicated with the Z. okay, indicated with the Z. So means the number of collisions takes place per second is called collision frequency. In case of binary molecule reactions or bimolecular reactions, these collisions are very high. They are from 10 to the power of 22 to 10 to the power of 28. And here each and every collision will not give us product. Okay. So here every collision will not give us product. Every collision, every collision, every collision will not give product. Every collision will not give us product. Only few collisions will give us product. That collisions are called effective collisions. Means some collisions in some collisions what will happen, simply the molecule collide with each other and they bounce back. But in case of some collisions they collide with each other and they will give us product. Okay, so which means each and every collision will not give us product. Only few collisions or certain number of collisions only will give us product. That is, they are known as what, children? Effective collisions. Means here each and every collision will not give us product. So means here collisions we can classify into two types. They are effective collisions, effective collisions, and ineffective collisions, effective and ineffective collisions. Okay, so in effective collisions only they will give us product. Okay, effective collisions gives product, effective collisions gives product, and ineffective collisions they will not give us product. Means not gives product, not gives product. Simply again the way after colliding, again the reactant molecule bounce back and they remains like the reactant molecule, but they never convert into product in case of effective collisions. Only in case of effective collisions only the reactant molecules are converted into product. Means here reactant is converted into product, but here reactant is not converted into product in case of ineffective collisions. Okay, so now here, so the number of collisions which will give us product is known as what, children? Effective collisions or fraction of collisions. And if effective collisions are indicated with F, indicated with the F. Means the fraction of collisions which will give us product are called effective collisions. So indicated with the F. Okay, next here, if any collision want to be an effective collision, okay, if any collision want to be an effective collision, what it must do? It must cross two barriers. Okay, a effective collision must clear the two barriers. Okay, an effective collision must clear two barriers. Okay, so what are the two barriers? They are, one is the energy barrier, and the second one is the orientation barrier. Okay, so an effective collision must clear what, children? Two barriers. Or if a collision want to be an effective collision, it must clear what, children? Two barriers. One is the energy barrier, another one is the orientation barrier. Okay, so now first let us see the energy barrier. Okay, what is the energy barrier? Okay, so energy barrier. Okay, energy barrier. So to understand this energy barrier, we need to observe the following graph. Okay, so now here let us consider, we are going to take or consider likewise. Okay, consider like this. Okay, so this is the x-axis and this is the y-axis. On x-axis we are going to take the energy, and y-axis we are going to take the reaction coordinate, reaction coordinate, reaction coordinate. Okay, so now here the reactant molecules, these are the reactant molecules. These reactant molecules are going to be converted into product. Okay, this is the product, and this is known as what, children? Threshold energy. It is called threshold energy. Threshold energy. And here this is the energy of reactant, average kinetic energy of reactant, and this is known as activation energy. Activation energy. Activation energy. Okay, so this is this total is known as what? Threshold energy, and this is known as activation energy, and it is the average kinetic energy of reactant, and this is the average kinetic energy or average kinetic energy of product, or average energy of product, or simply you can consider energy of product. Okay, this much is the energy of reactant and this is the energy of product. Okay, so here what is the meaning of threshold energy? Threshold energy means, children, the minimum amount of energy is required by the reactant molecule to give effective collision. Okay, what is the threshold energy? Okay, simply here we are going to indicate with the ET. ET means energy threshold or threshold energy. Threshold energy. Okay, so what is the threshold energy, children? The minimum amount of energy is required for the reactant molecule to cross the energy barrier. Okay, what is threshold energy? The minimum, this much amount of energy, this is the minimum amount of energy is required by the for the reactant molecule to cross the energy barrier. Means if a reactant want to convert into product, this much it must clear this much amount of energy. Means it should have this much amount of energy. Okay, so how we can define the threshold energy? The minimum amount of energy, the minimum amount of energy is required for the reactant molecule to cross the energy barrier, to cross the energy barrier, and so if you observe very carefully, already this reactant molecule is having this much amount of energy. So this is the extra energy is required for the, from here to here, this is the extra energy is required for the reactant molecule to clear the energy barrier. This is known as activation energy, EA, activation energy. Okay, activation energy. Okay, what is the activation energy? the extra amount of energy is required for the reactant molecule to clear the energy barrier. Okay, the extra amount means already this reactant is having in threshold energy, already this reactant molecule is having this much amount of energy, already it is having this much amount of energy, and this is the energy is required for the reactant molecule. This is only known as activation energy. Okay, so the extra amount of energy, the extra amount of energy, the extra amount of energy, or the extra amount of energy is required for the reactant molecule, for the reactant molecule to cross or to overcome or to cross the energy barrier. Okay, so this is known as what, children? Activation energy. Okay, so now, and here what about this? This is the average kinetic energy of reactant. Okay, this is the average kinetic energy of reactant R. Okay, therefore what we can write, energy threshold equal to average kinetic energy of reactant plus activation energy. Okay, this is the formula of threshold energy. Okay, so this is about what, energy barrier, which means if this reactant molecule want to be converted into product, it must clear this much energy barrier. Okay, so this is about what, energy barrier. If more activation energy, less rate of reaction. If less activation energy, more rate of reaction, which means rate or speed. Rate is inversely proportional to activation energy. Rate is inversely proportional to what? Activation energy. More activation energy, less rate of reaction. Less activation energy, more rate of reaction. Simply what you can understand, so this energy is increased. Okay, so it is very difficult to cross the energy barrier for the reactant molecules. If it is very less, so easily the reactant molecule can cross the energy barrier and more speed of reaction or more rate of reaction. Okay, so this is the about energy barrier. Okay, next let us see orientation barrier. Okay, so now orientation barrier. Okay, this is actually, it is the orientation barrier. Okay, we discussed about the energy barrier and energy barrier. Now we are going to discuss about the orientation barrier. Okay, so if a reactant molecule want to be converted into product, not only have the energy barrier, means it not only cross the energy barrier, and also it must clear the orientation barrier also. Means the reactant molecule should orient proper manner, then only they will give us product. See, for example, here A and A, B and B, they are oriented. This is the proper orientation. Then only it gives us effective collision and it will lead us a product. But if they orient in improper manner, means they are not going to orient properly, they are going to orient in improper manner, and even though they collide with each other, and also even though they are having sufficient energy to cross the energy barrier also, it will not give us product. Which means, children, even though these molecules are crossing energy barrier, but due to lack of what, orientation barrier, they will not give us product, and finally there is no reaction. And here they are consider they crossed the energy barrier and they oriented properly and they hit together and they will give us product. Okay, so this is about the orientation barrier. Okay, so based on this theory, Arrhenius given one equation that is known as what? Arrhenius equation. Okay, so first let us see We know here rate of reaction is directly proportional to F, fraction of effective collisions. Means fraction of effective collision increases, rate of reaction is also increases. And here according to Boltzmann theory, according to Boltzmann or Boltzmann factor, F equal to e to the power of minus Ea by RT. F equal to e to the power of minus Ea by RT. Means F, we know F is what? Fraction of effective collisions. And here Ea, what is the meaning of Ea? Activation energy. Next R, what is the R? R equal to ideal gas constant. Okay, what are the ideal gas constant or universal gas constant values? 2 calories Kelvin inverse mole inverse or 8.314 joule Kelvin inverse mole inverse. Okay, these are the R values. And what about the T here? T is equal to absolute temperature. Absolute temperature. So here what is the meaning of absolute temperature? Temperature scale we need to take in the Kelvin. Okay, now so here units for the temperature, what we need to take? Kelvin temperature only we need to take. Okay, Kelvin. That is only known as what, children? Absolute temperature. Okay, and next here according to rate equation, rate equal to K into concentration to the power n. According to rate equal to rate equation, according to rate equation or rate law, K that equal to K into concentration to the power n. Okay, once again we see according to which one we are taking here, according to rate law or rate expression, rate expression, rate equal to K into concentration to the power n. Rate equal to concentration to the power n. Okay, so here rate means speed of reaction or rate of reaction. And what about K? K is called rate constant or velocity constant or specific rate of reaction. Okay, so here what is the K? K is the rate constant, rate or speed or velocity constant or specific rate of reaction. Okay, so now here when we consider when concentration to the power n is constant. Okay, now when concentration to the means same concentration we are going to take for a same reaction, so now it will become the constant. And here what about the n? We know n is equal to order of reaction. What is the order of reaction? We will discuss in the further synopsis. Okay, so now here if you take the concentration to the power n constant, rate is directly proportional to K. Okay, so now you consider it as the equation number 2 and it has the equation number 1. Okay, so now from equation number 1 and equation number 2, when you compare there, rate is directly proportional to fraction of effective collisions, rate is directly proportional to K. Okay, so from equation 1 and 2, what we are going to be conclude here? K is directly proportional to F. K is directly proportional to F. Okay. So now here we know K is the rate constant, F is the fraction of effective collisions. We know fraction of effective collisions what? E to the power of minus EA by RT. Therefore, K is directly proportional to e to the power of minus EA by RT. Okay. So now here to remove this proportionality, we are going to keep a constant that is nothing but what, children? Arrhenius constant. Okay. So therefore, K equal to A into e to the power of minus EA by RT. Okay. So this is known as what, children? Arrhenius equation. Okay. Arrhenius equation. Okay. So what is the Arrhenius equation? K equal to A into e to the power of minus EA by RT. Okay. So in this A is called, what is A? Arrhenius constant. Arrhenius constant. Arrhenius constant. Okay. Right. So here Arrhenius constant is also have same units as what? Rate constant or speed constant or velocity constant. Means both K and A are have what, children? Same units. Okay. So just consider here both K and A are have same units. Same units. Okay. Right. So this is the Arrhenius equation. We know already. What is Arrhenius equation, children? K equal to A into e to the power of minus EA by RT. Okay. Now let us see the modified form of Arrhenius equation. Okay. So modified form of Arrhenius equation. Modified form of Arrhenius equation. Arrhenius equation. Modified form of Arrhenius equation. Okay. So what is the modified form of Arrhenius equation here, children? Simply what we are going to do, we are going to apply the natural logarithm in both sides. Okay. So when you apply the ln both side, so what will get? Ln K equal to ln A. So here E and Ln will get cancelled out. Directly what we can write here? Minus EA by RT. Okay. Minus EA by RT. Okay. Now apply the log in both side. Okay. So apply the log in both side. If you apply the log in both side, what will get? So now here 2.303 log K, that equal to 2.303 log A minus EA by RT. Okay. So why we are writing likewise, children? We know already ln equal to 2.303 log base 10. Okay. So base 10 sometime will write, will not write. Will not write means here base 10 only you assume. Okay. So now divide the equation with 2.303. Okay. Divide the total equation with 2.303. Okay. Next what we do? Divide with 2.303. Okay. So when you divide with 2.303, what will get here, children? So here 2.303 log K by 2.303, that equal to 2.303 log A by 2.303 minus EA by 2.303 RT. Okay. So each and every term we are divided with the 2.303. So finally what will get here? Log K equal to log A minus EA by RT. Okay. So these are the modified forms of Arrhenius equation. Okay. So from this Arrhenius equation, what we are going to do? We are going to do some conclusions. See what are that conclusions? First let us see. Okay. What is the relation between the K and temperature? Relation between rate constant and relation. Okay, we'll see. Okay, right. Relation between K and T. Okay, na? Rate constant and temperature. Okay, so what is the relation K and T? Okay, somewhat we'll write here. Okay, or else you take new page. So first let us see the relation between K and T. Okay, na? We can understand by using graph method. Okay, so now first take the relation here. Ln K equal to ln A minus EA by RT. Okay, this equation only slightly I am going to change. Means same equation only I am writing. Ln K equal to minus EA by R into 1 by T. So this is plus ln A. Okay, so it is just looking like what, children? So you take ln K on the y axis, 1 by T on the x axis, and this is the plus C, and x multiple is known as what? M, and here y equal to minus mx plus C. So such type of equation like we can assume. So here when you plot a graph ln K on y axis we are going to take, 1 by T on x axis we are going to take, and here what about the C? C is the intercept on the y axis. Okay, C is the intercept on y axis. Now how we are going to get the graph here, children? So here what is the x multiple? M. So here which value we are having? Minus value. So this is the graph we are going to get. Okay, so now here this is the C equal to ln A, and slope. What is the slope equal to here? Slope is equal to minus EA by R, which means ln K and 1 by T, how they are related? Ln K and 1 by T are related inversely. Means ln K is inversely proportional to 1 by T. Ln K is inversely proportional to 1 by T. Means from here to here 1 by T increases, ln K decreases. Okay, so now when you rearrange this, what will get? Ln K is directly proportional to temperature. Ln K is directly proportional to temperature. Means K increases, means temperature increases, K is also increases. Temperature increases, rate constant is also increases. Okay, the same graph we can plot in between by taking another form of the Arrhenius equation. So what is the another form of Arrhenius equation? You take the log K equal to log A minus EA by 2.303 RT. Okay, so now this equation also you will rearrange. How will get this equation? If you rearrange, log K equal to minus EA by 2.303 R into 1 by T plus log A. Okay, so now here log K you take on the y axis, 1 by T you take on the x axis. So this is the minus m and plus, means y equal to minus mx plus c. So here also how we will get the graph? In the same manner. Okay, so this is the y axis and this is the x axis. Here log K we are going to take. Okay, log K, and here intercept on the y axis, that is the log A, and here what is the on x axis we are going to take 1 by T, and here what is the slope? Negative slope with negative slope. Okay, so here what is the slope value? Here slope equal to minus EA by 2.303 R. Okay, so this is about the graphs related to what? Modified Arrhenius equation. Okay, next we can give the some other relations, right? Okay, so by taking the equation, okay, but take the equation that is log k equal to log A minus EA by RT, EA by RT. Okay, so in this equation, if temperature increases, what will happen? Temperature increases, EA by RT value, decreases. Why? Because here T is in the denominator. Okay, so denominator value increases, total value is going to be decrease. If EA by RT decreases, minus EA by RT increases. Okay, na? Minus EA by RT increases means this total value is going to be increased. Therefore, automatically K is also increases. Okay, means temperature increases, rate constant is also going to be increases. And if temperature is constant, if T is constant, we will discuss with the activation energy. Okay, if activation energy increases, if same reaction, if activation energy increases, okay, so numerator value, so if EA increases, EA by RT is also increases. Okay, na? If activation increases, EA by RT value is also increases. If EA by RT increases, what about minus EA by RT? Minus EA by RT is going to be decreases. If minus EA by RT decreases, K is decreases, rate constant is going to be decreases. Means rate constant and activation energy are inversely proportional, and here from this rate constant and temperature are directly proportional. Okay, so in this way we are going to give some conclusions from the this equation. And one more conclusion, that is one more conclusion we are going to give, that is if temperature is equal to infinite, if temperature is equal to infinite, if temperature is infinite, what will happen here? Ln K equal to ln A we can write, or K equal to A we can write. Okay, what is the meaning of infinite temperature? What is the meaning of infinite temperature means, children? The temperature after which there is no increase in the rate of reaction. What is the infinite temperature? The temperature after which there is no increase in the rate of reaction, that is called what? Infinite temperature. Okay, see, mathematically also you take, so we know ln K equal to ln A minus EA by RT. Okay, so here what is the temperature? We are going to consider infinite temperature. So ln A minus EA by R into infinite. Okay, so anything into infinite will become infinite, anything by infinite will become 0. Okay, therefore ln K equal to ln A, or K equal to A. K and A become equal when temperature is infinite. Okay, here what is the meaning of infinite temperature? Already I told you. Okay, so here once again listen, what is the meaning of infinite temperature? Generally we know temperature increases, rate constant is also increases, right children? If temperature increases, rate constant also increases. But after certain temperature, how much temperature you increase also, there is no change in the rate constant. There is no change in what? Rate constant. Such type of temperature is called infinite temperature. For example, at temperature T is equal to 30, rate constant is equal to K, and 40, 2K, 50, 4K, 60, 8K, 70, 16K, and after 70 even you do 80 also, even do you 90 also, 16K only it is there. Okay, means this temperature is called what? Infinite temperature. Means after this temperature, is there any change in the rate constant? No, there is no change in the rate constant. Such type of temperature only is called what? Infinite temperature. Okay, so this is about complete information about the collision theory and also Arrhenius equation. Okay, so let us summarize collision theory. Okay, let us summarize it. Okay, right. So collision theory. Okay, what is the collision theory? Collision theory explains how a chemical reaction is going to be takes place. Okay, according to collision theory, a chemical reaction takes place due to collisions, and every collisions will not give us product. Only few collisions only will give us product, and the number of collisions takes place per second is known as what? Collision frequency. Number of collisions takes place per second is called collision frequency, and here each and every collision will not give us product. Only effective collisions will give us product, and ineffective collisions are not give us product. Okay, so if a collision want to be an effective collision, it must cross two barriers. One is the energy barrier, another one is the orientation barrier. Okay, next, what is the energy barrier? We discussed in this, we have learned what is the threshold energy and what is the activation energy and what is the average kinetic energy of reactant. Okay, threshold energy is this is the threshold energy. This minimum energy is required for the reactant molecule to cross the energy barrier, and extra energy is required for the reactant molecule to cross the energy barrier, that is the activation energy and threshold energy. So threshold energy ET equal to average kinetic energy plus activation energy. Okay, next, orientation barrier. So orientation barrier also necessary for the effective collisions. Not only energy barrier, orientation barrier is also necessary for the effective collision. Okay, so here means the reactant molecule should orient properly, then only they will give us product. Okay, if they are not orient properly, they will not give us product. Okay, so based on that, we are having Arrhenius equation. We derived the Arrhenius equation based on rate is directly proportional to fraction of effective collisions. Fraction of effective collision equal to minus EA by RT. Okay, and rate equal to K into concentration to the power n. Okay, rate equal, what is K we given, and we derived this relation. Okay, next, this is the modified form of Arrhenius equation, and graphs related to the modified Arrhenius equation, and relation between the K and temperature, relation between the K and activation energy, and what is the infinite temperature. Okay, so I hope you have understood this concept, collision theory. So if you like our efforts, our teaching skill, you please subscribe for the more videos. Okay, thank you for watching.